Okay, everyone, I believe you have watched the three YouTube videos. Okay, um, so now let's write down some notes. Okay, so first go to your notebook. Okay, so distance education notebook, page 2.3. Okay, go to page 2.3. Okay, the first note I would like you to write down will be this. Okay, just copy it down on your notebook. So, what is a proton? What is a neutron? What are neutrons? Also, what are electrons? Okay, the important information here is just remember protons are positively charged. Okay, remember write this in your notebook. Okay, neutrons has no charge, and electrons are negatively charged. Okay, now as we said in the video, for every atom, from periodic table, there will be a mass number. Okay, so I show you. Okay, so if you have a, sorry, you don't have to go. Just say I use this as example. Okay, so if I tell you, okay, I have a, I have a, I found some elements. Okay, uranium 238. Okay, 32. Here, 92. Sorry. Okay. Okay. So if I tell you, okay, I have a box of element which are uranium 238. What does it mean is, okay, so the 92 here is the atomic number. Okay, so I just write down like that. Atomic number tells us, okay, the number of protons. So please write it down in the nucleus. Okay, please write this down in your notes. Okay. So the number upwards here, the 238, okay, is a mass number. Okay, it's called mass number. It means, okay, the number of neutrons and protons in the nucleus. So for uranium 238, okay, what's happening is in the nucleus. So remember in the nucleus, okay, remember the element looks like this, the nucleus in the middle, and I have electrons outside. So electrons outside. Okay, so I just try to sketch a graph. Electrons outside, the nucleus is in the middle. So in the nucleus, okay, there are 92 protons. Okay, so the rest, say if I use one color here, the rest here, okay, will be neutrons. Okay, and the number of proton and neutrons should be 238. So if you do your math, okay, all this together should be 238. We have 92 protons. My neutrons should be 238. Take away 92. Do your math. You can use your calculator, but for physics students, try to do it by hand. So we have 446 neutrons. Okay, so that's way. Yeah, that's what's happened. Okay, so every time someone writes you a chemical symbol, okay, with the atomic number and also with the mass number, you should able to extract the information here, okay, from this. Okay, that's why. Well, that's the way scientists communicate. They write something down. You must be able to read this. Okay, so if you look through your notes, okay, go to page 2.4. Okay, that's that's how the formula is. Okay, you don't really need the formula. Okay, so the atomic number are down there, number of protons. Okay, mass number is on the top. Okay, the difference between them will be the number of neutrons. Okay. Also, the number of electrons will be the same as normally will be the same as the number of protons. Okay. So there will be not for this element there. Okay. There will be 92 protons, 146 neutrons, and also 92 electrons outside. Okay. Now, also, there's something more important about the atomic number. Let's go to a new page. Actually, yep. Okay. Now, the atomic number is the most important information of an element. Okay. What's happened is, if I have, let's go through. Let me show you. Sorry. Let me show you. Actually, let me show you. A periodic table first. Let's use this one. Okay, the internet is a little bit slow. Just bear with me. Okay, now if you have a look in the periodic table, all the element has a atomic number. For instance, hydrogen is 1, helium is 2. So, blah blah blah. Atomic number is assigned to each individual element. So if, say, let me take carbon as example. Okay, so carbon has an atomic number of 6. Okay, normally, the mass number will be 12. Just normally. Okay, so somehow, if we all know atomic number means number of protons. If I add a proton to carbon, somehow I add a proton to carbon. Okay. The atomic number of the element will be 7. And once the atomic number changes, once the number of proton changes, this element won't be carbon anymore. It would change. Okay. Then we go through here, nitrogen. Okay. So the carbon will be nitrogen. Even through the math number will be 13, even through look like that. So the idea is if you are able to add or subtract a proton from an atom, the atom is no longer the original atom, it changes, its property changes, carbon changes to nitrogen, or something changes. So this is called a nuclear change. Okay. This is called a nuclear change for your information. It's different to chemical changes. Okay. A nuclear change changes the number of protons or neutrons in the nucleus. So, okay, but the main thing is atomic number changes, the element changes. So atomic number is really important. Okay, now, however, the difference is, say if I have carbon 12, okay, somehow I bombard, I give it I add a neutron to it, say it would be carbon 13. Okay. So if I add a neutron to it, it's still nuclear change. Okay. The carbon 12 would change to a carbon 13, but it's still carbon. Okay. So the element changes after the change of atomic number, not the mass number. So that's the difference. So if you, by the way, if I give you some carbons, even you take it to NASA, if you take to the best university you ever know, with the best equipment, they still cannot do this. Okay, because the theory is, well, if I show you, this is very hard to do. So what I mean is adding a proton into a nucleus. If we're able to this, we'll be able to manufacture all these different elements, including gold. So imagine one day, well, the scientists tries doing research on it, but they still cannot. There's no way to do it. If you can figure out a way to say platinum has a atomic number of 78. Okay, so if you can figure out a way to add a proton into the nucleus of platinum, then it will be gold. So, and this technology is not happening yet in today. So, okay. However, it happens nuclear bomb. Happens in the nuclear bombs, but not with gold. We cannot manufacture gold this way. So, yep, just letting you know, this is really hard to do. We cannot do it today. So, yep. Now let's go back to your notes. So, if you go to your notes, okay, it tells you this. Okay, and then, okay, the simple is go through that. Okay, now here's your practice questions. Okay, so you can now go to your page, have a read at your textbook, go to page 7, do those questions. Section 1.1, question 1, 2, 3, 5, and 10. Okay, 1, 2, 3, 5, and 10. Okay. The answers is on the back page of your distance education notes I show you. The answers will be on page here, page 2.12, okay, with the solution of 1.1. Okay. Try to do those questions, and well, if you need me to go through it, send me an email. Okay, yeah, because yep. So now let's move on. Okay, let's move on to the next part. Actually, before you're doing those questions, just stay with me. Okay. Let me go through the notes. We need to go through that in order for you to do some question, to do some question. Okay, so the next part on your notes on page 2.5, the quirks. Okay, here are the introduction of quantum mechanics, okay, which is not in the syllabus. Okay, it's not in the year 12 syllabus. So if you're interested in them, have a read. Okay, but I'm not going to don't spend too much time on it. Okay, they are not in the syllabus. You won't be tested in year 12 or in year 11. Okay, so we can just forget about them now. If you're interested, just read the YouTube or read the notes. Here is an important part. Okay, nuclear stability. Remember, you need to write down some notes, but you don't have to write down the exactly same notes as I wrote there. So just make sure, okay, you captured all the important information in your own notes, and that's it. Okay. Nuclear stability. Okay, so the idea is, sorry, again. Okay, the idea is, okay, if I found something, if I dig my backyard, I found something. Okay, and normally it will be stable. It means it means if I pick a rock from the ground, the rock normally it wouldn't emit radiation, nuclear radiations, because it is nuclear, because it's stable. So, okay, because most nuclears are stable, okay, but sometimes it's not. For example, uranium. Okay. Sometimes uranium, they gave out radiations. Okay, so so how do we know that? Okay. So on here is a stability graph. Okay, also is a stability graph on your textbook page. Just let me have a look, page 11. Okay. Now I have a copy here. I show you. Yeah, something like this. Okay, just let me enlarge it. Okay, so the idea is, okay, if you have a look, there's a black line there. The line is called the stability line. Okay, this black line here. So just let me move it. Okay, now the x-axis here is your atomic numbers, number of protons. The vertical line is the number of neutrons. So what's happening is the scientists, they plot all the elements on this graph. Okay. So the element stays on this black line, okay, will be stable. So for example, if I pick up a rock, it won't emit nuclear radiation. I won't die. Okay. However, if you have some element from other places like this, okay, somewhere there or somewhere here, if you hold it on your hand, it's likely you die. Yep. So because they emit nuclear radiation. Okay, and the general rule is, if you have a look at it, normally most of them won't. Okay, the general rule is, the line stop at here at atomic number 82. In some book it's 83. So the general rule is, okay, if you have an element has atomic number, write down, if the atomic number is greater than 83, okay, atomic number, it must emit some sort of radiation, whether strong or weak. For instance, if we go back to your periodic table, okay, now Okay, so 83 is somewhere just after code, somewhere here. Okay, so if you pick up an element somewhere there, for instance uranium 92, okay, is radioactive. All the element has a greater atomic number than 93 is radioactive. So just be careful with what you hold in your hand. Normally, uh, the most yes, the one we need to get familiar will be uranium. That's the nuclear source of atomic bomb. So yep, okay, that's what it is. And I leave you, yes, I leave you some time to do those questions. Okay, so and we go on, we keep going in the next video. Thank you.